Hello everyone, welcome back. This is Engineer Hussein Mwasabi. So in this video, we'll look at how to find the largest area that can be filled. Now this condition is under the aspect of the applications of differentiation. Alright, so before we begin, do not forget to like and subscribe to the channel. Alright, let's get to it. So I'm going to explain this condition with an example. Now the question says, a man has a farm that is adjacent to a river. Suppose he wants to build a rectangular pen for his cows with 500 feet of fencing. If one side of the pen is the river, what is the area of the largest pen he can build? What is the area of the largest pen he can build? Alright, so the key here is literally just to find the dimensions. Once we find the dimensions, we can easily calculate the area because the area is what we want. The area of the largest pen that he can build. Now, let's create a schematic to easily understand what's going on. Alright, so what's going on is that he wants to build a rectangular pen for his cows with a certain fencing. Then one side of the pen is a river. So let's draw a random river. So let's assume that this is a river. Alright, so it's a rectangular pen. So one side, let's consider this as one side. This is just one side now, but the rest is rectangular. Like that. Therefore, since it's rectangular, this would be our length and this would be our width. And because it's rectangular, we expect this side to also be the same. So that is a visualization of what we have. So now to draw it neatly, I'll just erase this part so that I can draw the river to just cover the rectangle. Like that. So that's what we're having. So now we have that. Let us now find the dimensions. Now to find the dimensions, be mindful that we have been given the perimeter. The perimeter is given in the statement where it says, suppose he wants to build a rectangular pen for his cows with 500 feet of fencing, which means the perimeter is 500. Therefore, since the perimeter is equal to W plus L plus W, giving us the perimeter to be equivalent to 2W plus L. The perimeter is 500. So say 500 is equal to 2W plus L. Now remember, you can make either W or L the subject of the formula, but in this case, it's quite easier to make L the subject of the formula because if we make W, we end up having fractions. So you can either pick whichever way you want to go with this, but I'll go with L. So making L the subject, I'll have, so I can write this as 2W plus L being equal to 500. Then the 2W can go the other side and I'll have L being equal to 500 minus 2W. So I'm having my first equation. Now remember, it's the area we're interested in. So area is equal to L times width. We have the length, which is 500 minus 2W, then times W. Therefore, area is the same as one writing W times 500 minus 2W. Therefore, area is equal to 500W minus 2W squared. Now, once you reach this point, all you're supposed to do is to differentiate and determine the critical points, because the critical points will give you the values that will show you if the area is the maximum or minimum. So, to find the critical points, all you have to do is to differentiate or find the values of the variable that you have in the first derivative. In this case, we're having A with respect to W, as you can see. But I can just say A prime, which is short for dA over dW, is equal to, if I apply the power here, I'll have 500 minus 4W. Now, this means that we have our first derivative to be equivalent to that. Now, at the critical points is where the first derivative is equal to 0. So I'll let a prime be equal to 0. Once that is done, it implies that I'll have 0 being equal to 500 minus 4w. So then for w, it implies that the minus 4 can go that side, and you have 4w being equal to 500. Now, we want to solve for w and not for 4w, so we divide both ends by 4. By doing so, we'll end up having the value of w to be equivalent to 4 into 500. That will basically give us 125. So that is how we did. Then we can easily find the length from this equation. Therefore, the length is equal to 500 minus 2. The value of w is 125. Computing this, 500 minus that, we end up having 250. Now be mindful of this. At times, you might find the first derivative and you end up having a case where maybe the w was squared and you ended up having maybe two values of w, let's say plus or minus. All you have to do is to still find the values of L, which could be two values, and see to it that which area that you're going to find will give you the largest area. So in this case, I'm looking for the largest area. So area is equal to L times W. So area is equal to my length, which is 250, times my W, which is 125. Then my area will be equivalent to 31250. Then I'll just say units squared, and that will basically be my area. So this is the largest possible area of the largest pen he can build. Now don't forget, in a case where you end up having two values of W, you can always find the other values of L, which will be two values of L. Then once you do that, the first value of W, which gave you the first value of L, try and find the area and do the same for the second values. Now, by inspection, you will see that there will be a difference in those areas you'll find. One of the areas will be bigger than the other. Then just get the biggest area because you're looking for the largest. But if they said the smallest, you look for the smallest area. But the procedure is one and the same. You do the exact same thing I've done here. Remember, the key is to just know the quantities that are hidden in the question. Then differentiate them, find the critical points, then find the values of the variables in question, and you'll find the dimensions. After that, find means of manipulating the procedure. Alright, thanks for watching. If you have questions, you can reach me on WhatsApp on the line 077 149 5252. Remember, slow progress is better than no progress. And let's remember to strategize before becoming a statistic. Let's try and push for that. A+.